The Gigatron is assembled and it seems to be working. I'm going to put it inside of this nice, I think it's cherry case. Added some hinges. So we have the ports in the back. This is for the joystick or the keyboard, VGA, audio, and then mini USB power. I approve. It came with this Famicom knockoff controller, the DB9, which is kind of unusual. Well, they probably got it like that because, you know, you can't really just buy Nintendo ports off the shelf. There we go. All right. I think if you push the select button, okay, yeah, can you see that? Let's zoom in. Okay, when I push select, you'll see the scan lines change. So they're solid, half, quarter, and not much at all. And it doesn't look as dark on this camera, but it does look fairly thin looking at it in person. So basically what it does is it exchanges drawing the screen for more cycle time, right? So when you have it filled like this, it's quite slow. And then when it's thin, it's spending basically all the black lines doing more computations instead of drawing the screen. Let's see. Racer. This sounds good. Oh, look, I'm a car. All right. Okay, so I'm driving down the road. Okay. Oh, look at that. Look how slow that is. Blah, blah, blah. Okay, now I'm going to increase the compute time. See how it speeds up almost immediately. And then if I go into this mode, it's quite fast. Because this doesn't have a dedicated video processor. It's probably synchronizing everything to the VGA frequency, which I believe is 25 or 24 megahertz. So it's probably using that as the master timer. So if I had to guess what it's doing, it's not updating every horizontal pixel, probably every 4 pixels, because VGA does not actually have a dot clock as you're putting pixels into memory horizontally. It only has a H-sync and a V-sync. So basically, you could fill the pixels as slowly as you like as you go across the screen, and I believe that's what's happening here. So the horizontal resolution is probably divided by 4, so that would be, what, 640 divided by 4, it should be 160? That looks about right. Tetranus? Gee, I wonder what this is going to be. I can't believe it, it's a Tetris clone! Let's go into slow mode. Look at that update. Bloop, 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 bloop. How do I rotate? Oh, I push up to rotate? That's counterintuitive. I have noticed it does seem like you can't actually push 2 buttons at the same time on this controller. I wonder if that has something to do with how they address it. I mean, this controller probably just has a shift register in it, but they're probably you know, basically bit banging it with registers, if I had to guess. There's no music. The rest is just the same, isn't it? Let's see. Yeah, let me try something. I think you hold start to get back to the menu. I'm going to push up and start. See how that doesn't work? But if I hold start by itself, then it works. So yeah, it looks like you can't push 2 buttons or more at the same time. So loader, I believe it can actually... Okay, this is a little convoluted. There's a PS2 adapter, which consists of an AT-Tiny 85, I believe. And you can actually use this as an EEPROM, because there's probably like about 1K of EEPROM on this, to store programs. All right, so I think what I'm going to do is I'm going to swap in the new ROM that they sent me that has improved BASIC as well as Microsoft BASIC. Let's take a look. going to use my very, very old screwdriver. Screwdriver is like 35 years old. It's one of those Radio Shack ones that was made in Japan, so it lasts forever. What are you talking about, Doc? All the best stuff is made in Japan. So I'm going to plug in this convoluted thing. It's a DB9 to PS2 adapter with the microcontroller on it. So they're probably having to communicate over a SPI-like serial interface to this microcontroller, which is then communicating to the keyboard in serial. So I'm sure they had to pull some real shenanigans to make that work. Okay, this keyboard works. The other PS2 keyboard I had didn't work, but it was kind of a fancier one. So this one's simpler, so I guess that bodes well in its favor. Pictures, oh, this sounds exciting. Well, what's going on? Are these the people who developed it? I think you've got some memory leaks going on. All right, how do I get out of this? End, Control C. Oh, page down looks like that's doing the scan line thing. It seems like it's still moving at the same speed. I wonder if they changed the code. Let's try Microsoft Basic. Oh, Commodore Basic. Well, Commodore Basic was Microsoft Basic. Commodore had a pretty sweet deal. Something like they licensed Microsoft Basic for their computers for perpetuity for like $50,000. And they use it on the PET and the VIC-20 and then the Commodore 64. And I don't think they actually relicensed it and actually added features until the Commodore 128. Let's see if this works. Oh my, that's quite slow. What was it to speed it up? There we go. Okay, list 10, print. Of course, oh, I'm not used to this keyboard. It's also got the pipe character in a weird place. Let's see if we can. Control C. Okay, that worked. Let's do something a little bit more involved. Let's see. What's that thing that, what's his face? 8-bit guy always does. He makes like that line maze. Okay, let's do this. New 100, A equals int rand 1 times 10 101. If A is less than 6, then print that part of the maze, and then semicolon, return, else print the other part of the maze, semicolon, return, list, okay, 10, go sub 100, 11, go to 10. Ugh. Wow, even in fast mode, it's pretty slow. I think the online documentation was saying that there's no tokenizer. Tokenizer is where you type in a line, and it's like, oh, he typed the word go to. Well, we're going to assign that a token so we don't have to actually parse the text every time. We can just say, oh, there's the go to token, like an opcode. Apparently, this doesn't have a tokenizer. It has to interpret as it goes, so that makes it slow even in basic terms. When I just noticed Envision, one of the eyes is upside down. I guess they thought that looked cool. All right, let's get out of this and try the Tiny Basic. All right, I found the instructions online. See, the start button is page up. So yeah. We'll see if that allows me to exit to the main menu. Tiny Basic. Hold me closer, Tiny Basic. Well, this has a lot more free space. All right, let's try that same program. A equals int rand. It feels a lot more responsive already. guess, oh, pipe character, that's not right. Whoa, syntax error. Maybe it does random numbers differently. Oh, let's see. Print rand1. Okay. Print rand. Syntax error. Oh, that gave me a number. Interesting. Oh, okay, I see. So it's returning a whole number for random. So I can just do a equals random 10. There we go. Not much randomosity in that. Oh wait, did I lose a line of code? I did. Heavens. It's the uncola. Why do I keep losing line 101? What the heck? If A is less... Am I getting syntax errors in it? I guess I should pay attention better. Return. Okay, what's the syntax error? Okay, what is the syntax error? If A, maybe it's the space. If A is less than 6, print. What the? Oh, I can't go. Am I limited to one line? I think I'm limited to one line of text. See that character that pops up? Okay, all right, so let's do this. 101, if A is less than 6, then 110. Okay, I guess it accepted that. 110, print, not that, print that. Come on, nope. Finally. Man, that is a very picky basic. Wow, these patterns. I don't think it's very random. Well, I mean, you can program this in basic. Oh, that's okay, that's actually a decent speed up if I do that to the screen. All right, let's break out of that, and then let's see, what was it? Page up is start. Let's see if holding that takes us to the menu. It does, great. I wonder what Apple One is. Well, I mean, I know what an Apple One is. Apple One on TTL. 600 free, 600 bytes. I'm assuming these are locations in memory. I forgot how this even works. Okay, so the memory location, well, that's a hex value. So if we did like 000, it would show us what's in the beginning of memory, 0001. Okay. I think you have to enter all, no, you don't have to enter all 4, okay. Okay, yeah, you only have to enter the first 2 if you're in the first page of memory. Okay, I'm trying to think. Oh, I think, yeah, it, well, here. What was that before? It was 280? I think it's 280. That's the memory location. Well, oh, man, this is a pretty good emulation of WASM monitor. You can't even go backwards. 280R should vector to that. There we go. Wow. So WASM monitor, for those who don't know, it was well, it was basically this. It was a way to type in memory locations into the Apple One. I believe Steve Wozniak wrote it in, I want to say it's either 64 bytes or 128 bytes. But it was enough to give you access to the memory, and then once you could do that, then you could execute other things such as, programs off tape or basic. Okay. Disassemble. Okay, I wonder what that is. Oh, that's cool. It disassembled its own memory. So disassembly is when you take machine language and you turn it into, well, mnemonics so humans can read it. Let's see. So load Y, load A, star. So it's, yeah, this thing is emulating a 6502 in this situation. Oh, a Mandelbrot set. I'm sure this is going to be a speed demon. I don't think we're going to set any deep dive records with this. It's important to realize with the Gigatron that the CPU, or, well, approximation of a CPU, because, you know, it doesn't actually have one, it runs at a pretty decent speed. A big thing slowing it down is that it has to spend a lot of its time drawing the screen. So in a way, it's kind of like the Atari 2600. Although the Atari 2600 wasn't really, you know, slicing up the image like this. It was doing its calculations in the vertical blank. Yeah, but, you know, for what it is, this runs pretty well. And, you know, if they had some sort of dedicated video chip, they would, you know, complicate this even more. And you'd have to have probably a separate area of RAM, so you'd need more RAM. So, I mean, this is a pretty good compromise. Oh, it's got a decent amount of colors. Is this how long it actually takes to make those deep dive Mandelbrot set videos on YouTube? They just edit out all of the calculation part. If you notice, it actually goes pretty quickly on the solid colors, but where there's detail, it slows down quite a bit. The mathematical wonder of the Mandelbrot set. I always wonder if they deep dive far enough in the Mandelbrot set, they'll find like an alien or some sort of like Star Trek V God sort of thing, and it'll be like, "You found me," and then William Shatner would be like, "What does God need with a Gigatron?" And then he'd be like, "It will be my chariot." That's not the worst Star Trek movie. The worst Star Trek movie is Star Trek Into Darkness. Terrible, terrible film. Star Trek V, yes, has a lot of issues, but it's an interesting failure. You know? I think movies can be interesting failures. Like pretty much every movie the Wachowskis have made since The Matrix has been an interesting failure. Well, I don't know. I didn't see that movie where, what's her face? Mila Kunis is made of bees or something. I didn't see that one. Seems like that would be a good bad movie night movie. We're supposed to have a bad movie night in April once Max gets his new house, and hopefully Cats is on video by then. Maybe we could rent Jupiter Ascending as a second movie. I figured that's what you wanted. You just wanted to, like, you know, come onto YouTube and listen to me ramble on about nonsense while we wait for a CPU-less computer to render a single frame of the Mandelbrot set. I mean, that's what the algorithm demands, right? Mm-hmm. Oh, yeah. That looks pretty cool. Very toroidal. Oh, we got this nice, beautiful Mandelbrot set, but there's like a timer just sitting on the screen. Oh, that must be minutes. Oh, you know, the disturbing part is if that's minutes, and that means that's hours. Is this what it's like at like Pixar, where they're like, oh, we got to render this movie about a rat that cooks food, and oh, great, one frame of it is done. Well, I will see you guys in 300,000 years once we've gotten to the bottom of this particular Mandelbrot set. Okay, let's try the snake game. Eat food, not poison. Well, that's good general purpose life lessons. Oh wait, so my poop becomes poison, not food? I think a lot of dogs would disagree with that. It seems in this version of the ROM, it does a better job of keeping the speed reasonable even when you're drawing this solid blocks. Because if you notice, I mean, it is a little faster when I go into this mode, but not incredibly so. But then if you remember, in the Malderbrat set, obviously there's a lot more calculations going on. That did slow down significantly. So they might have some sort of like time slicing with some games. Well, that's interesting. When I go to pictures, you can see one of my basic things still there in the background. So this must be basically a couple pages of like video memory, and they're just scrolling through it and overwriting it. And here is the credits screen. This Gigatron TTL computer kit was brought to you by Marcel van Kervinnik and Walter Belgers. Tyrannus is by AT67 and Bricks by Xbox. Special thanks must go to Mark, Paul, Ivana, Oscar, Marchinj, Eric, Chuck, Ben, Dieter, Martin, Brad, Lou, Phil, Brian, David and Dave, HG, and all fans. Thank you guys for sending me a Gigatron. It was a lot of fun to assemble. And when I took this to the Vintage Computer Festival Midwest back in September of 2019, it was by far the most interesting thing on my table for everyone that attended. People were just fascinated with it, which is pretty cool because I think I had the only one at the show. Yeah, so there you go. That's the Gigatron. When I did the first video, it did work right off the bat. It wasn't there weren't any problems. It just took me a long time to get around to making the follow-up video because I actually didn't have a PS2 keyboard that worked with it. But the other day, I got one. So here's this video.